Okay, now let's move on to 8086 microprocessor. So today I'm gonna teach about 8086 from the starting with the basics. Okay, so let us see what all I'm gonna teach today. 8086. First thing, I'm gonna teach about the futures of 8086. Then architecture. Then um, about the flags affected, which is again under the architecture itself. Then comes the comparison of 8086, then the pin diagram, and details of pin diagram. Okay, now I'm gonna teach about all this. So now let us move on to what how it is called as 8086 and why. 8086, it the first point is it is an 16-bit microprocessor. Then it is also called as 20-bit address. Okay, so this 20-bit address tells us how much storage it can be stored. So it is 2 to the power of 20 bytes. This is nothing but 1 mega bits, 1 megabyte. Okay, so 2 to the power of something, 2 to the power of 1, 2 to the power of 2. These powers tells us number of bits that can be stored in a microprocessor. Okay, now how many memories does a microprocessor have? So in 8086 it is divided into 4 segments. What memory is divided into 4 segments. So first one is code segment. Code segment is denoted as CS. Second one is data segment, is denoted as DS. Third one is stack segment, is denoted as SS. Then the last one is extra segment, that is denoted as ES. So if this is the memory location, the each bit stores of the same size. Each are of 16 bit, that is code segment, data segment, stack segment, and extra segment. Each stores of 16 bits. It's all called as 16-bit registers. Okay, so now in a memory is divided into different segments and each of 64 kilobytes. So the portion of memory where use subroutine programs as well as data is stored. It even uses subroutine programs, and the data is also stored. Then main code is stored in code segment and data is saved in data segment. Code is saved in code segment. Then the data is saved in data segment. Sorry, don't mind for my dirty handwriting. Any questions you can ask me in the doubts questions. Okay, now let us move on to the architecture of 8086. 8086. So architecture of 8086 is divided into two parts. The first one is BIU and the second one is EU. BIU is bus interfacing unit. EU is execution unit. Bus interfacing unit is used to fetch the information, information, or read or write to memory. That is, input and output is taken from BIU. Then it transfers the information to and from the memory. To and from the memory is done. Now what is EU? EU is execution unit. Execution unit, it will do all the operations. Like addition, subtraction, multiplication, division, and it mainly takes all the information from BIU. Let us move on to the diagram of an architecture. So it is divided into two parts. So divide it into two parts. So this is gonna be our BIU. This will be our EU. So the whole architecture is divided into two parts. The first, memory. So this will be our memory interface. BIU interface, it gives the information now. So the BIU should collect and store it in each segments. The memory is divided into 4 segments, that is code segment, data segment, stack segment, and extra segment. Stack segment. So now this, sorry, bad at drawing, please don't mind. So this will be the first part where all the memory is stored into each segments. Then the bus which collects the information from these segments passes through the instruction queue. Instruction queue are of 6 steps. So each bus will take the information from the input. It will bring each and everything and store it here. 6, 5, 4, 3, 2, and 1. So this is called as instruction stream byte. Instruction stream, or it can be called as an queue also. So from here it passes through the control system. Control system passes through the bus. Then the bus gives the information to the ALU to do all the arithmetic operations. If the answer is ready, it again gives back to the bus. This is gonna be our A bus. This is gonna be our C bus. This will be our B bus. And then everything is stored in operands. If it has any extra answers and flags are getting affected, then it passes on to the register to give us the input. registers are AH, AL. AH is the higher, AL will be the lower. Similarly, BH, BL, CH, CL, DH, DL, and then comes all the pointers, that is SP, stack pointer, BP, base pointer, SI, stack index, DI, that is gonna be the destination index. So this is gonna be our, then from here it gives back again to this memory location, the output is given back. So this is gonna be the architecture of 8086. So the need diagram is shown here. You can make a note of it. So from memory the data is collected and given to the instruction queue, and it gives to the execution unit. Instruction queue is 6 byte. BIU is used to fetch the data, as I told. Memory is divided into 4 segments. It has 2 or more registers, that is stack pointer and instruction pointer. So instruction pointer is of 16-bit registers. Then the information queue is fetched the data and passes the information to the control units. Operands are used for temporary registers. Okay, now flags. There are 9 flags. So these flags, there are 6 and 3. The 6 are the status flags, 3 are control flags. Status flags are nothing but conditional flags, as I have told in the previous video where when I explained for 8085 microprocessor. You want it, you can check it out even for that. So the 6 conditional flags are the carry flag, auxiliary flag, zero flag, the sign flag, and the overflow flag. This is the new one which I am going to explain it here. The parity flag is already explained. The 3 conditional flag, the 3 control flags are the trap flag, then the directional flag, then comes the interrupt flag. So let us move on in detail. I will give you the brief about this also. So now what is carry flag? Carry flag, when the last bit is high, then is set to be set. If it is having the result of an arithmetic ALU, if it is having a carry, then it is set to be set. If it is 0, then it is set to be reset. What is auxiliary flag? Auxiliary flag, when the auxiliary flag, when the register is from D3 to D4, when it has a carry, then the register is set to be set. Otherwise it is set to be reset. Then comes the parity flag, is the operations. If the number of ones, the result contains number of ones, then it is set to be set, even number of ones. If it is odd, then it is gonna be 0, so it is gonna be reset. This I finished, this I finished, this I finished. Now moving on to zero flag. Zero flag is nothing but if the result of ALU is 0, then it is set to be set. Otherwise it is set to be reset. Moving on to sign flag. Sign flag is nothing but if the D7 bit alone is 1, then it is set to be set. Otherwise it is gonna be reset. Now what is an overflow flag? Overflow flag is when the result of the operation is more than the 16 bit. If the result is more than 16 bit, then it is said to be set. Okay, otherwise it is gonna be in reset condition. I repeat, overflow flag, the result of the operation is more, remember, more than 16 bit, then it is said to be set, otherwise it is gonna be reset. Now let us move on to the control flag. Control flags, the first one, that is trap flag. Trap flag says the operation to be done step by step. That is what is trap flag. Now moving on to directional flag. Directional flag is nothing gonna be strings. Strings in the sense it says what to be first, that is move from one register to other register, that is the first string. Similarly, if it is addition, first add this one with this one. This is what is called as strings. Now moving on to interrupt flags. When the main execution is occurring, there is some small interrupt, that is called as interrupt flag. Okay, what is an interrupt flag? When the main execution is occurring, then there is some small interrupt, that is called as interrupt flag. See, now you are executing something, that means you are typing something in the Word document and suddenly you close the button and you will get an interrupt saying that you save the document, then close. This one will be okay and this one will be cancelled. So this is called as an interrupt flag, which interrupts you from doing the main programming. So while writing a program, there is some interruption which is getting interrupted to the microprocessor by doing the program which you have given. So that if that is the case, if the interrupt is occurred, then the flag is set to be in set condition, that is high. Otherwise it will be in reset condition, continuing with your program, that is 0. Thank you. So with this I end up with 8086.